Welcome to the project demonstration of wireless wildfire monitoring system using sensors. So here we are using sensors like fire detection sensor from the flame detection sensor, and next gas leakage. If is there any harmful gas leakage happened in the fire in the forest, so it will be identified by this gas sensor. It's MQ02, and live temperature monitoring with help of LM35. So these three parameters continuously stream into our mobile phone through the ESP8266 Wi-Fi module. So the whole system getting power supply from this adapter, so which will take 230 volts AC input and provide us a 5 volts DC output. So in real time application, when we place this kit in forest, we can use the battery which is a rechargeable from the solar panel also. And coming to the interfacing connections, LM35 for temperature monitoring, interface at A0 pin, and flame sensor to detect the flame, interface at A1 pin, and gas MQ02 sensor interface at A2 pin. So these three are the inputs to the PIC16F73 microcontroller, and the output from this ESP8266 Wi-Fi module from the B0 B1 pin from here. And the next is, on this motherboard we have the three major important components. So one is our microcontroller, which is interfacing between the inputs and controlling the outputs. And next, the steel plated one is the crystal oscillator, which will provide us 20 megahertz of oscillating frequency to the controller. So the main purpose of this crystal oscillator is, so we have provided the set of instructions in embedded C language to the microcontroller. Each instruction line need one pulse, so that controller can execute 20 mega instructions per second, as we are providing 20 megahertz of clock frequency to the microcontroller. So that is the speed of our microcontroller. And the third component is the reset switch to restart the microcontroller. So this capacitor is to provide the continuous power supply whenever the spikes generated from this regulated power supply adapter. So this will neutralize them. And this is the power LED indication, and this one is the program LED indication. And from these pins we are going to load the Xcode, means programming code, to the microcontroller directly. So let us see the demonstration. So before on the kit, we need to do some steps in a mobile phone. So first of all, we need to install the application that is a Juice SSH from the Play Store. And next, go to hotspot settings of your phone and change the hotspot name to project 5341 without any space and without any capital letter. The next password should be 129 and a band 2.4 gigahertz. So these three are very important. After that, on the hotspots, and you can see there is no device connected now. So after switching on the power supply, our system will connect it to this hotspot enabled mobile phone. There you can see one device will connected here. Right, so one device connected. And now go to the application part. No need. Actually it will come with like empty. I'll show you the delete. Right, now so check the IP address. The correct device is IP address 192.168.60.65. Note down that. So now manage connections, add a new connection. So we need to do three changes. One is the local, type is telnet, and IP address we need to enter is 192.168.60.65. So which we got from the settings of our mobile phone. So let me check it, 190.168.60.65. Right, and third is port number 8080. And enable. Now click on OK. So there we will get the continuous streaming of temperature. So whenever the temperature increases, so we will get the alert in our application. So it crosses 55 degrees centigrade, then automatically high temperature alert message will be displayed on the application. And if the fire detects, so alert fire detects, and if there is any gas leakage detects from the forest, same gas leakage detects. So these are the alert messages continuously we can stream into the application.